Welcome to the ABL Diagnostic webinar series. Today we will discuss about the management of the APOBEC mutation through the DeepChek HIV Proviral DNA genotyping assay and software. For your information, this webinar will be registered and we will be in a position to share the recording and the slide of this presentation on demand. If you have any questions, don't hesitate to ask in the chat conversation or at the end of the presentation. We will open the microphone for your questions. So today there will be 3 parts in our presentation. First of all, there will be an introduction of the DeepChek HIV assay from RNA or DNA. It will be presented by Dr. Sofiane Mohamed and Antu Fachin from ABL Diagnostic. In the second part, there will be a live demo of the DeepChek HIV software for APOBEC mutation analysis, and it will be performed by Mr. Laurent Deblier from ABL. And in the third part of this presentation, there will be a presentation from Professor Evelyn Sharover from the CHRU Nancy, title A Delphi-type consensus for routine APOBEC mutation management in proviral DNA samples. So we will start with the introduction. So please make sure that also your microphone is muted, and I will give the end to my colleague Antu.
Sofiane.
Sofiane.
Good afternoon, everybody. So I will present you a quick presentation of the DeepChek HIV assay for drug resistance and genotyping using RNA and or DNA. So first of all, what are GHHS recommendation for drug resistance testing. So as you may know, RNA drug resistance is recommended for acute, chronic, and pregnant people with HIV. And also RNA drug resistance is recommended for patients with virological failure for 1,000 copies per ml, and also between 500 and 1,000 copies per ml with integrase inhibitor, and also for low viral load above 200 copies per ml, but for this viral load, the testing may not be successful. So that's why it recommended to use DNA drug resistance for undetectable viral load or low-level viremia. To follow the recommendation, so you can use our DeepChek software, our DeepChek assay, because we can use different input like RNA or DNA. After that, you will perform the RT-PCR or PCR according to our protocol, because we have several protocols for target specific or whole genome. And after, you can perform the sequencing through Sanger sequencing or NGS. For drug resistance interpretation, you will use our software. So here you can see some extraction kits that we validate, like the Maxwell, the Cayam from Cagen, EasyOne, MagnaPure 96 from Roche or McCord. So now I will show you several studies. So here, the author wanted to compare NGS and Sanger sequencing. For that, they used a whole genome kit from ABL and the target specific from ABL, and they used the ISeq 100 sequencing, and they compare with the Sanger sequencing using a ViroSeq. So here they were able to detect several subtype like B, C, D, A1, F2, and some recombinant form. They were able to amplify whole blood from 12 samples. And in this study, they were able to detect a minority mutation with NGS, but not with Sanger sequencing. And they said that the NGS was faster than Sanger sequencing. So now, in this study, the author wanted to see the clinical impact of the minority variant, that they use our kit and software. And here, 77 patients were undetectable or had below 200 copy per ml HIV RNA. And here you can see the subtype. We have B, A, C, and 2 recombinant form. So the author observed for half of patients they had APOBEC mutation between 3 and 56% of prevalence. And here the minority variant still unclear for the clinical impact. So the author said that we need further analysis to know the impact of the APOBEC mutation. So here in this study, the author compared two different sequencing methods. Short read, they used our whole genome kit with the ISeq 100. And for the long read, they perform house amplification for polymerase and envelope, and they used a Pacific Bio sequencing. They used plasma 16 RNA samples and also 3 DNA from Buffycott. For RNA, they observed a very good correlation for drug resistance interpretation, but for DNA, they observed some discrepancies for drug resistance mutation. For the protease target, here you can see for the whole genome, they detected some minority mutation below 20%. And for the RT target, they observed only with the DeepChek whole genome assay APOBEC mutation, 2 APOBEC mutation. So the author will perform more samples to confirm their found. So to conclude, here the NGS genotyping resistance for Proviral DNA is now commercially available. So it is recommended to perform Proviral DNA for undetectable viral load or low viral load. And Proviral DNA can provide additional information like APOBEC mutation. But here we need to interpret with caution because the clinical impact is still under investigation. So further studies are needed to determine the clinical utility of the Proviral DNA, and there is a need to standardize the protocol and the software. That's why IBL can provide you the entire workflow to detect some drug-resistant mutation in Proviral DNA.
Thank
So
you,
now,
Sofiane.
yes.
Yeah, thank you. I will give the end to Antu for the rest of the presentation of the ABL assay. Antu.
Okay. Thank you, Mathieu. Thank you, Sofiane, for the introduction. So from my side, I will give to you an overview about our DeepChek HIV workflow for DNA and RNA. So this part is really the practice for the wet lab part. Once you have the RNA or extracted DNA, you can perform the target amplification with the RT-PCR or nested PCR. Depending on the kit you use, target specific, the full polymerase or whole genome, you can follow the dedicated EFU for the amplification. Following the amplification, you purify the amplicon by using our magnetic beads, following by the quantification and normalization. Once you normalize on samples on amplicon, you can pull on amplicon together from each patient together to perform the library preparation. We currently have two different versions of the library preparation, V2 and V3. I can detail you in the following slides. We make the final quality control before sequencing by using index Zembron any Illumina cartridge, and our assay is also compatible with other sequencer like Thermo Fisher and also MGI, and the output could be analyzed by using our DeepChek microbiology software. So Okay, regarding the target amplification by our DeepChek assay, for RNA or DNA, you can follow the RT-PCR. Depending on the assay you choose, the target specific, full polymerase or whole genome, you have several quantity of master mix to prepare and then run your RT-PCR. Once your PCR finished, you can check the PCR product on the gel electrophoresis, and then make sure that you use the compatible ladder to be sure about the expected size of your band. Then perform the nested PCR, and again we verify the product of nested PCR by using a aerogel 1 or 2%. After the amplification, you can use our DeepChek NGS cleanup beads to purify the amplicon. The principle of the purifications is very simple. You mix the beads, the magnetic beads, with the DNA. Some minute for the binding, then separation on the magnetic stand. You wash twice with alcohol and elute by using elution buffer or water before transferring the purified amplicon to the new tubes. The second part of this slide to show you just to make you understand that our magnetic bead is not something compatible only with our DeepChek assay. You can use as a generic bead for any size selection for your other NGS workflow if you need. After the purification, we quantify by using any fluorometer like cubic quantities, and then normalize on amplicon to 3 nanogram per microliter before pulling all of them in accumulator in the tube per patient. And then we can start to prepare our library. As I mentioned before, we have two versions, library prep v2 and library prep v3. This slide shows to you the workflow of the library prep v2. The sample of one patient, most of the time we have big fragment depending on the application, but typically for HIV, we have the fragment from 700 base pair to more than 3,000 base pair. We fragment in a smaller fragment around 300 base pair. The extremity will be repaired and add an aid by a combinant enzyme in a single reaction, and then we can ligate the adapter that contain the barcode to identify patient. After the adapter ligation, we do a purification, following by a quick PCR, a S cycle, and a final purification to obtain the library. So this is the library prep v2. It takes around 2.5 to 3 hours. And a new version of our library prep v3, it takes 2.5 hours. Once we have the pool applicant, we will use a fermentation a fermentation combined with a kind of magnetic beads. We add the beads, a quick amplification, a quick incubation at 55 degrees for 50 minutes. Then we will stop the fermentation by using a stop buffer at the room temperature. We will wash twice by using a wash buffer provided in the kit, and then an amplification and ligate the adapter in the single reaction, and the last purification. So as I mentioned before, the library preparation V3 is a little bit faster than the first one. It takes around 2.5 hours for obtaining the library. Of course, library prep v2 or v3, we have the compatible adapter provided with the library prep. Once we obtain the library, we go through the final quality control. So the quality control consists to quantify by using qubit or any other fluorometer that we have enough quantity. We check the quality of library by using bioanalyzer or tape stations or any equivalent instruments to be sure that we have a good distribution of the library and we do not have a dimer primer, or at least not so much compared to the library. If in the case we do not have the instrument, we can use an electrophoretic gel to check the distribution. So the different, you can see that on the first line is the marker, and from the line number 2 to number 6 is the different library. The difference between the library is and the PCR product is, in the library case, we should obtain a kind of smear with the more significant signal around 300 by pair. Okay, as you can see here, from the line number 2 to line number 6. Once we check our library, we have a good distribution. We can normalize on applicant, on patient, and pool and make a final pool at 2 nanogram per microliter. When we have a pool at 2 nanogram per microliter, we have an equivalent of 10 nanomolar. Okay, so this is the theory. So that's why at the end, once we obtain the final pool, it's very important to check again the quantity, re-quantify the final pool to make sure that you have 2 nanogram per microliter. In the case that you do not have to, it's important to do the calculation to convert to 10 nanomolar. And with your final pool at 10 nanomolar, you can make the final dilution before loading on your sequencer. Depending, there are 2 examples for the I6-100 and MySic V2. But of course, depending on the instrument you can follow the dedicated dilution. So this our assay, our library preparations are compatible with any Illumina sequencer, I6-100, MySic, NextSic, or MiniSic, and our amplification is compatible with also other sequencer like Thermo Fisher, and we also have recently the library preparation for MGI instrument.
Thank you, Antu. Thank you very much for this presentation, Antu. I will give now the end to Laurent, who will perform a live demo of the software, showing in particular how the APOBEC mutation are managed in our platform.
Okay, thank you, Antu. Thank you, Sofiane. for all the to explain us how to produce those NGS data. And now with those NGS data, we need a software to manage them. And ABL is also providing software. So we have a web-based new platform which are able to manage many NGS data from different disease, viruses, and bacteria. So here we will show you how to run easily into this software NGS HIV data, and also more explaining you how we providing APOBEC information inside the clinical report. So in this platform, we always involving the platform, and what is important is the way you have to load your NGS data, and we try to have a quite easy front for you. So let's select a run name. So what is important is that you can upload all your sequencing files coming directly from the sequencer inside the software. So we have different software information. So easily, you just have to select your NGS data. In this case, it's directly the FASTQ coming from the sequencer, and the system will detect and group them based on the FASTQ name. And then you can edit, change the sample date, link to patient if it's important for you. And once you are ready, the system will allow you to upload the data and run DeepChek analysis. The pipeline can be configurable for all your needs, and you have the possibility to store some profile data in the system. So I will take the default one at first. The step pipeline will allow you to select the target region you have in your FASTQ. Also selecting the subtyping characterization method, and we have also a tab for configuring the expert systems option. So you can tell the system what are your minimal coverage, deep coverage you want, selecting also the noisy threshold, also activating or not some mutation filtering on the system. Next, you have to configure your final genotyping clinical report. So in the system will provide you two kinds of report. One report is a full genotyping report, so we will have all the information on multiple pages. And we have also a one-page report who will focus on one single reference threshold for the mutation. So in this case, for the demo, I will show you with the ANRS. We will also select that we want to see all mutation, and with highlighting of the mutation of interest based on ANRS. I select 3 thresholds, so I want the resistance interpretation at 5% level, 1 and 10, and 1 and 20. And I did say for this report, I want my reference threshold would be the 20%, which is quite the equivalent from the Sanger data, but you will also have the information for NGS. The report have a special APOBEC activity assessment section that can be activated or not in that report. The system can also allow you to add your contact information in the report or not. The last step, so you have configured everything, you can store that profile to be reused for your next analysis, and you can share this profile with other user of or laboratory. And you can also ask to have an email notification when the analysis is finished. So once everything is okay, I just have to click on Start Analysis. The system will prepare the run, will start, and you see a new run is being uploaded. This new run have my 2 samples that I have selected before. You have the file and the size of the file. You have sample type. I didn't mention the sample type, but it could be mentioned. And you can see that the analysis is starting and is running. Depends of the time, the size of your FASTQ, of the NGS data. The analysis can be quick or can take more time. It really depends of the depth and the number of reads inside the FASTQ. So for the test, I can directly go on the test I made just before, and then we can directly review the results. So it's the same 2 samples, but I run it just before. So let's open, for example, the sample APOBEC 1. And you have the system is providing you an interface to show you sample information that you mentioned, and you can follow from the quality control tabs. On that tabs, you will have information about noisy mutation, coverage filtering, and so on. You have also information about the number of reads that has been mapped to the organism. You have a nice coverage graph per region. So we have the protease in this case, we have the RT. This is dynamic, so you can zoom and go inside the coverage graph, and you can go into amino acid position or going into directly in nucleotide position. And we have a small table that giving you the mean, the average read count, the mean coverage, and the low covered position. So in this case, we see that my RT is not well covered on the end. Then we have a tab for the drug resistance information. So in this case, I select INRS. We have the 3 threshold and each drug class. When resistance is detected, for example, in this case at 5%, we have a resistance detected, you can see which mutation and the percentage of this mutation, the prevalence of this mutation directly in the system. So just passing you. We have the subtyping detected by the system with the similarity, and also we have a mutation tab. This mutation tab can is dynamic. You can filters by prevalence to have to just display some range of them. And what it's interesting also is that we can highlight mutation of interest with a small comment explaining why this mutation is interest for which algorithm. We have also the possibility to configure that grid and adding if the mutation is listed by APOBEC, or if this mutation is listed by APOBEC as a drug resistance mutation. We also adding a small message behind this grid with the list of the mutation that we detect over the reference threshold. So in this case, is all mutation from APOBEC over the 20%. You can order also by bicolon. And then we have the possibility to download information from the analysis. So we generate consensus 20%, but also we will generate variant color VCF at the VCF format. We have a CSV export with all mutation detected. So what is in the grid, but also mutation that has been discarded by our expert system. And we have the possibility to review the two clinical report that I mentioned before. So if I review the full genotyping report, I can review it, adding some command and change the status for the clinical part. I can also switching directly to one of them. And you see, this report will regroup all information in a PDF format that you have seen in the interface. So one by region, you have a mutation tab with all mutation that passing the expert system, and you have the prevalence. You have also the Q-score of the mean Q-score of each position. If some APOBEC mutation are there, it's also listed behind the grid. And then you have all the information. You have also the coverage inside that report. And if I go to the one-page report, it's a more clinical report that we can share with the clinician. This report is more easy to read. You have only one assessment, and the assessment is the assessment at 20%. But we're listing also drug resistance mutation below the 20% on the right column. You have the information of the covered position, the subtyping, and also behind that report, you have the mutation detected and this mutation could result from a DRM mutation.
Thank you, Laurent, for this presentation of the software, highlighting the APOBEC component. I will now come back to the presentation.
Okay, thank you.
And I'm giving you the end to you, Professor Schrover. I hope you can hear us well. And we are ready for your presentation.
Hello, everyone. Can you hear me?
Yes, we can hear you very well. Thank you.
Okay. So can you give me the first slide, please? This is the part of the talk when we are going to speak on how we can communicate with our physician. And we have a first part of the talk on the HIV DNA testing in the lab routine, but on low HIV viral load in plasma or in HIV DNA provirus. And for the second part, we will examine how we can manage in real life of our monitoring the APOBEC mutation. Next slide. So here I'm going to present to you general data obtained in a recent study we have performed last year with Cédric Artard and Anne-Deferry. And in our group, we want to know better the ABL diagnostic system in a low viral load under 1,000 copy per milliliter. And we wanted to enhance the laboratory capacity for monitoring drug resistance, not only in plasma viral load, but in our HIV DNA, namely globular sediments. In our laboratory, we called DNA for the provirus as globular sediments, and also in a very important compartment in cerebrospinal fluid. Next slide, please. So we had 12 infected patients, very well followed by our physicians, partner physicians, and they were mainly male with the mean of age of 50, regularly infected by subtype B virus for 2/3 of the patients. We obtained 17 plasmas and 19 globular sediments. Additionally, we had 7 CSF. And for these patients, we used the DeepChek assay genotyping drug resistance directed to protease, RT, and integrase with 2 PCR. And we had 7 high viral load patients for plasma, globular sediment, and CSF, and 5 low viral load patients for plasma and globular sediment. We fixed for these patients the mutation cutoff for APOBEC at 20% and 5% cutoff. Next slide, please. And I cannot give you the detailed results because the revision is in progress, but the most important data are as following. We observed 10 mutations detected only in globular sediments, while in the other compartment, the neurological compartment, we observed 2 specific mutations. So arguing in favor of a compartmentalization of the resistances. And when mutations were detected in CSF and plasma, frequencies were higher in CSF. But when we use the mutational load, considering that the absolute quantity of the resistance variants are important to be taken into account, the quantity of genome was higher in plasma. And additionally, you can see that the results obtained for the follow-up in plasma from very high viral loads to low viral loads when the treatment pressure is effective a few weeks after are very good. And you can see, for example, for the patient 10 and the protease gene, that the residues which were mutated, either in the 16 residue or in the 20 residue, showed a mutation, high viral load of mutational variants, which were very next to the obtained results a few weeks after on the same residues in very low viral load. So it's a very confident technique, and we were a bit surprised, to be honest, to have so good results. Next slide. And for these results, which will be, we hope, published in a few weeks, we also observe the compartmentalization of the mutational variants. And here you can see in the figure either the plasma compartment or the DNA the proviral or globular sediment compartment and the CSF. And you can see that the 5% cutoff increased the sensitivity of mutation detection as expected in the different compartments, except in the CSF. So in this compartment, this neurological compartment, we obtained the same sensitivity either with 20 or with 5 cutoffs. Next slide. Now, concerning the use of the APOBEC mutations according to the DeepChek software, we have just begun a few weeks ago, and we are discussing regularly with the physicians, and you are going to see it in progress. And as it was explained before, we use the APOBEC mutation having a drug resistance impact following the ANRS guideline as usually in France. Next slide. So we have 18 mutations up to now, either in the protease gene or in the RT gene and in the integrase gene. Some of them are well known, as an example, on RT gene, the 184R, mutation, which is quite regularly mentioned. You will see where. Next slide. So where it is mentioned, this kind of mutation, you have two examples here. The first example is the report which we start to discuss with our physicians. And here you have a patient infected with the genotype 2 very frequently represented in France. And you have in the left the mutations observed. The sensitivity is 20% in the left and the sensitivity is 5% in the right. And you can observe on the right part of the report that we observed the mutation 230I, but at a cutoff of 9 and nearly 10%. So when we discuss with the physicians concerning the carboryl regimen as a long-acting solution, which is regularly asked for by the patients, we will suggest that the patient has to be followed regularly to be sure that we will not have the emergence of the mutations, arguing in favor or avoiding the real prevalent choice. The second slide, the following slide, please, is the example 2 to show you that in Proviral DNA, we can also observe permutated residues. And as you can see in this example, we have the combination of the mutation in 184R and in 230I. And in this case, and sometimes we have 3 mutations, such as this one, and it is in favor of permutated residues, very often accompanied by defective viruses. And this is not a way to avoid treatment which could be used. Next slide. So we had a few publications interesting in the recent months, and this one, the Swiss cohort study was quite interesting because they, in the materials and method, they confirmed that we have with lung PCR on HIV-1 genome the possibility to obtain a quite good NGS sequencing, and we have some failures, but the quality of the techniques is correlated to the quality of the isolated DNA. Next slide, please. And if we can summarize the results, we had a lot of sequenced samples, more than 600, and we obtained at least one major drug resistance mutations with a cutoff at 15% in 55% of the patients. But when we consider the DRM without the DRM signature linked to APOBEC, we decreased to 24% of the patients only. And you can see in the right part of the slide that the APOBEC linked mutations are in bold, and they have to be taken into account essentially when they are combined, and we don't have to change the regimens too easily. Next slide. And for the third part of the slide, this will be to summarize. Maybe a few of them have heard of that. The work which has been done in France by the NRS consortium. And it wasn't done because many disparities in the clinical use of HIV DNA sequencing were observed. So a Delphi type consensus was initiated in France to modernize the use and the techniques, and mostly all the interpretations of the results. So physicians, 47 physicians and virologists, 21 of our teams were invited to propose guidelines and to vote. And this was quite easily to conclude, as you will see. Next slide. We have very clear guidelines on these 2 points. So on the left, you can see that indications for HIV DNA genotyping and interpretation are quite easy to decide for HIV RNA not detectable. And when you have an absence of cumulated HIV RNA or incomplete previous genotype, so a poor history of the clinical and therapeutical patient. And for RT protein integrals, as you know, it was the same before NGS solutions. You have a good positive predictive value of HIV DNA genotyping, except for APOBEC. Mutations linked to APOBEC have to be excluded. And you have the negative predictive value, which is insufficient. Next slide. Concerning the virological successes observed in a lot of our patients, you have usually the question of long-acting ARV introduction. And when you have HIV DNA genotyping, it is useful if RNA data are not sufficient. It's quite clear. Oppositely, in case of virological success, if treatment is chosen during 4 to 5 days a week without any change in RNA molecules, no HIV DNA genotyping, even though RNA genotyping data is introduced in the discussion. Concerning the third case of virological success, in case of a decrease in the number of RNA molecules, HIV DNA genotyping, if RNA genotyping data are available, will be a good solution. Next slide. And at last, for the combinations of mutations, well known, the 184I in HIV DNA combined to 2 other mutations in 41 residue and in 230 residues, will be an association of a defective genome, and this could not be changed the indication of the treatment. If mutation APOBEC, you will have to take care of the reports and of the patients with caution according to the whole clinical data available in your hands and previous ARV treatments. And this is a condition where we have to discuss a lot with physicians, and in a few months we will be able, I think, to conclude in complicated cases. And we agree mutations linked to APOBEC enzyme have to be mentioned on HIV DNA genotyping report. So we have chosen to mention them above 20% with a clear confidence, and between 5 and 20 cutoff. We will have to construct clinical study to give more detailed recommendations. Next slide. So as a summary for this HIV DNA Proviral follow-up with the physician, it is quite clear that the indication of DNA HIV-1 genotyping in case of rare previous HIV RNA genotyping is important. And when you have controlled the HIV-1 viral load with the aim to change our regimen, it will be a good solution. But when you have HIV-1 genotype to be analyzed with caution, you will have to discuss with the physicians first according to the percent of viral mutated variants, and we will decide what we will do above 20% and between 5 and 20% cutoff. We will have to discuss as a multidisciplinary meeting to adapt antiretroviral treatment and decide for the future guidelines. And thanks to the help of the industry or bioinformatics in more general conditions to optimize the bioinfo filter. Thank you for your attention, and maybe you have to discuss on your experience on that in the field. Thank you.
Thank you, Dr. Schrober, for this very interesting presentation. So I propose now that we can move to a question and answer session. So please free to type your question in the chat, or even if you have access to a microphone, that if we can hear you, please feel free to raise your hand for asking your question. So for now, I don't see any hands rising. So perhaps let me check also in the chat. I don't see any question for now. So perhaps while we are waiting for questions to come, I would like to thank you everyone to join the webinar today. Please feel free to contact us to access the recording of this session, or to access the different presentation, or to ask for any additional information you would like to have on this topic. We remain fully available for any question or information you would need. So perhaps if nobody has question, I will thank you everyone again, and I hope you will join also our next webinar that we will announce in few days. So thank you very much, everyone. Last chance perhaps to ask your question, and if not, have a nice end of the day.